Hello, we're going to start with section P.1, and this is going to be a review section. We are going to go over order of operations, algebraic expressions and formulas, uh, inequalities, absolute values, and real number properties. And look at look in this video because I will bookmark each section so you do not have to watch this all in one time. Okay. The objectives here. So order of operations. This isn't actually an objective to this chapter, but I always find it's a good idea to review order of operations. It's something we tend to forget about. It's giving me a little problem here. So your order of operations, usually what you've heard is PEMDAS. So your parentheses, exponents, multiplication, division, addition, and subtraction. I just want to go through this again because one of the things we tend to get confused by is what is really the parentheses cover? Or P cover says not just parentheses, this is actually groups. And exponents, so E is not just exponents because it could be exponents, but it could be roots as well because roots are a kind of exponent. Multiplication, division. A lot of times we think we have to do multiplication first, then division, but we do this going left to right. And the same thing with addition and subtraction. A lot of times when people look at PEMDAS, they forget that once again, it's whatever comes first going left to right. Like I said, PEMDAS is a very nice way to remember your order of operations to kind of keep in your head. Is very simplistic and can be a little confusing. So order of operations agreement. The agreement goes like this. First thing we do is we perform operations inside grouping symbols. So we mean grouping symbols. So grouping symbols could be parentheses, could be brackets, could be braces, but we also have other things at work, like if we have a division bar, the division bar also works as a grouping. We group in the top and then we group the bottom. Sometimes you can argue that if we have something inside of a square root, that square root would also be considered like a grouping. We just don't put the parentheses there, but we know we have to do this first before I can deal with the square root. We perform operations with your innermost parentheses and we work outwards. So if an algebraic expression involves a fraction, you treat the numerator and denominator as if they were different, separate parentheses. Like I said, why we don't just say it's parentheses first, because that is a little confusing. So if we do have group parentheses or brackets, because usually we mix them up a little bit. We know we're supposed to do what's inside parentheses first before we deal with this bracket. Evaluate all expressions, or sorry, exponential expressions. So as I said, that's an exponential expression. Well, that's also an exponential expression. Square roots are also part of your exponents. We'll get to that a little later, but roots are another form of an exponent. So when you're thinking exponential expressions, it's not just simply it has to have an exponent. But also this gets pulled into groupings too. So we know we have to deal with this first in these parentheses before we do this grouping, but when we have a square root, we don't have those parentheses, but we know we have to deal with this first because this technically is a grouping. The rules aren't as straightforward as they appear. Also performing multiplication and division, we do those together because they're essentially the same operator. So we do multiplication and together as a grouping. It's not just multiplication first, then division. We do them together. We just do whichever comes first going left to right. Same thing with addition and subtraction. They're essentially the same operator as well. So we don't just do addition first, then subtraction. We do whichever comes first, once again, going from left to right. So once again, just going back to parentheses, when parentheses occur within parentheses, we can make different shapes such as the bracket or the braces. All of these have the same meaning. When parentheses occur within parentheses computation, the innermost one must be done first. And sometimes you'll have two inner ones, or sometimes you'll have one inside of another one inside of another one. You just have to try to go to the one that's most in the center. And if you have like two or three of them, they're most in the center, then you just do those one at a time. So for some examples here, if I have 5 minus 3 plus 5 squared minus 2 times 5, by order of operations, the first thing I need to do is a grouping. So we have a grouping here. We have these parentheses. First thing I need to do, this is 5 minus 3, which is going to leave me with a 2. At this point, once I get down to just one number, I can drop those parentheses. So one thing to always remember, this is an equivalent expression to this expression. So we have to put that in equality, the equality there. So let me change the color here just so we can see this. Next, we're going to have our exponents. We only have one exponent to worry about. So we do that 5 squared. So we have 2 and 5 squared, 5 times 5, 25. Next we're going to do is we're going to look for multiplication / division, whichever comes first, going left or right. We only have one to worry about here. So remember that is a negative 2 times 5. So that is going to be 2 plus 25. That my negative 2 times 5 is going to give us a minus 10. Trying to find a color I haven't used here yet. Let's use this red. For our last step here is going to be addition and subtraction. Whichever comes first, going left to right. In this case, the first one going left to right is going to be the 2 plus 25. So that's going to be 27 minus 10. Then we only have one more left, the 27 minus 10. That will leave us with 17, which is our final answer. We're going to do this again. Sorry, I was trying to get my utensil back. Once again, look for the grouping. So we have a grouping here. Now, when we go inside that grouping, we go back to order of operations. So we have a grouping. So first thing we see we got addition and subtraction. So going left to right, the first thing we have is the 2 minus 4. So I have to deal with that. 2 minus 4 is going to leave me with a negative 2, and then we still have the 5. Put the square out front. We still have the grouping. Now going left to right, we just have this addition to take care of inside that grouping. So every time you have a grouping, you're basically restarting your order of operations inside of it and going through them again. So negative 2 plus 5 will be 3. So we're going to have 3 squared. We don't have a grouping anymore. So when you just have parentheses around a single number, that does not mean a grouping sign, because a lot of times we use parentheses to signify we have multiplication. Or sometimes if we have something with a negative in it and we want to say that there's that negative that's attached to the number, we will put that parenthesis around it. It's not telling us it's a grouping in that case. So the grouping is gone as long as there's only one number left behind. But in this case, this is the part we have to deal with next because I have 3 times 3, which is going to be 9, because I have to do my exponent. Now, going left to right, multiplication and division, I hit the division first. But because I hit the division first, I have to do the 6 divided by 2 first, which is going to give me 3. Now I can do the multiplication because like I said, multiplication, division, you do which one comes first going left to right. So division first, now I can do the multiplication. We're going to go up here and complete. So 5 times, or 3 times 5, it's going to be 15 minus 9, which is going to leave us with a 6. Now we're going to simplify again, but we have a different grouping symbol. So like I said, it's not always parentheses. Uh, we're going to go back to absolute values here, but we have groupings here. We have the division bar is causing a grouping. So we get a grouping that is up here and a grouping that is down here. But we also get an additional grouping because we get a different color. We have this absolute value. So sometimes we have other operators that are going to make a group for us because this is an operator itself. We're doing an absolute value. You can kind of treat that as a grouping too. And if you're ever confused, feel free to ask questions. So because we got these couple groupings here, technically the absolute value is the innermost one because it's inside this top division bar. So as far as the division bar goes, it doesn't matter which goes first, top or bottom. Just do whatever. In this case, we only have to worry about the top. There's nothing going on the bottom. If we do the absolute value part here, we have -3 times 4, so absolute value of -12. We're going to go back through absolute value, but all absolute value does, a little note here, it just turns your number into a positive. If it's positive, it's positive. If it's negative, it becomes positive. But I still have to go with this operator here. So also, absolute value is kind of put together with like exponents sometimes, and you see the rules that you have to do both of these before we can move forward. So exponents and absolute values, both you want to perform those before you do multiplication or division. So we get 12 plus 2 over 7. Now we'll go back to the groupings again. I took care of the innermost grouping. It's all done with. Now I have a grouping on top, which is 12 plus 2. It's going to give me 14. Technically, 7 is a grouping, but since it's a single number, there's not anything I need to do. So that is just going to leave me with a 2. All right, so take a moment. You should have your worksheet. Work on these problems so you'll have 1 or A, B, and C here. It's just practice for yourself. So take a moment and work on those and then come back and I'll run through the solutions. All right, so hopefully you paused and ran through this. Don't worry if you get this wrong. Mistakes actually help you learn things better. So if you see you made a mistake, don't worry about it. You'll probably actually have learned this better by making one. So we have a brace, and then inside that brace is a bracket, and inside that's a parentheses. So we need to start with innermost grouping, innermost parentheses. So we're going to start with the 5 plus 6. So 4 minus the 7, or bracket 7 plus brace, oh sorry, yep, brace 7 plus bracket 2, got those backwards, minus, so then this 5 plus 6 minus 11. And then we close the bracket and then we close the brace. Now, once again, this is the innermost grouping, once again, so we have the brace, but the bracket's inside of it. So now we have 4 minus brace 7 plus, so we have 2 minus 11. So because it's a negative number, Sometimes we'll just leave that parenthesis behind to signify that we have, in fact, a -9 left behind. Remember, if there is a single number inside of parentheses or even a bracket or a brace, that is not, it's not telling you there is a grouping. It's just telling you that we want to make sure that negative stays with the number. So now my innermost grouping, 4 minus, we're going to make our brace, 7 plus -9, so that's going to be -2. So we got 4 minus -2. So a negative and a negative becomes a positive if you don't remember. So that becomes 4 plus 2 is going to equal. B, we have the division bar again. The division bar is making a group and a group. Only one of them we have to worry about, which is the top one. So if I look at the top group, I don't have exponents. Well, I don't have any more groupings. I don't have any exponents or absolute values. I go to multiplication and division. And what comes first with multiplication and division is the 6 times 9. So, sorry, 6 times 3, not 6 times 9. The 6 times 3 is going to be 18. So we have 18 divided by 9. And we still have that -2 in the bottom. So we're still completing this top grouping. So 18 divided by 9 is going to be 2. 2 divided by -2 is just going to leave me with -1. Okay. So once again, we have absolute values again. So that works as a grouping. We have a grouping. And inside that grouping is another grouping. So we do innermost grouping first. So it's going to be the 10 divided by 5. So absolute value, 10 divided by 5 is now going to be 2. So now we have 2 plus 2 and absolute value, power of 3. So like I said, absolute value is going to be treated like a grouping. So we have inside of your absolute value is a 2 plus 2, which is 4. Absolute value of 4 happens to be just 4. Now I'm just have 4 to the power of 3. 4 times 4 times 4. Ooh, sorry, I almost dropped my pad there. That'd be 64. One more surprise prompt. I forgot about this one here. So part of the reason I put this one here is that sometimes when we have these more complicated parts to simplify, we forget about something like little old -1 out here. So always try to pay attention because sometimes you have a tendency to kind of make numbers drop off once you deal with the more complicated parts. But once again, we have a grouping on top and a grouping on bottom. So if I start with the grouping on top, we have 6 divided by 2 times 3. We have multiplication division are my only operators. So going left to right, the first ones I come to is 6 divided by 2. That is going to be a 3. And then times 3. And then we still have 9 minus 2 cubed on the bottom, minus 3. Like I said, it doesn't matter if I simplify the top first or the bottom first in my division bar. It's just usually I go top first. Now we only have one operator in the to deal with and make this just one number. So we have 3 times 3, which is 9. That's going to be over 9 minus cubed minus 1. The top is taken care of. Now we go to the bottom. So we don't have another parenthesis, but we do have an exponent. We have 2 cubed. All right, so 2 times 2 times 2 is going to give us 9. Or sorry, 9. It's going to give us 8. I'm sorry if my voice is going. I got over bronchitis just before doing this. So now doing the bottom here, we have 9 minus 8. It's going to be 1. So now we just have the division to take care of. Here is division bar. So 9 divided by 1 is 9. And now we can finally do that last operator, the addition and subtraction part, and we're just left with 8. Okay, moving on to our next subject, we're going to go through algebraic expressions. So if a letter is used to represent various variables, various numbers, we call that a variable. So just bear in mind that just because you have a letter doesn't instantly make it a variable. There's another case where we use letters that represent what we call constants. So they represent a number that we know a value to. Example would be when you talk about E equals mc squared. We know that c represents speed of light. There is a constant attached to it. Just bear that in mind for future problems. But right now, if we have a number, it's supposed to be representing a variable. So it just means that it's a number that can vary and keep changing. A combination of variables and numbers using the operations of addition, subtraction, multiplication, division, powers, roots, absolute values, other things like that, that's called an algebraic expression. So examples of algebraic expressions: 3 plus 2 times 7 divided by 8. I don't know what that is, but that's an algebraic expression. We got numbers and we have operators. If I said I have 3 and then I want to add on an x plus 7, well, we have numbers, we have variables, we have operators. That's also an algebraic expression. If I have just variables and operators, that's also an algebraic expression. Also, a number by itself is an algebraic expression, or a variable by itself is an algebraic expression. But as long as you have a number or a variable, we consider an algebraic expression. But what's also important here, there is no equal sign. Algebraic expressions do not have equal signs. As I say here, expressions do not have equality or inequality signs. You won't see this, or these signs either. So evaluating algebraic expression, a lot of times I hear people say it's solving. This is not solving. Evaluating algebraic expression means we're going to find the value of the expression for a given value or a variable. Also, this as well, when I say evaluating the algebraic expression, that would just mean use order of operations. I was going to write O, and then I realized that's just confusing. So that means also you mean order of operations. Sometimes we'll say evaluate the expression. We're just mean that we just want to simplify it down to one number. That's why math gets confusing. We use the same phrase to mean several different things. All right. Evaluating algebraic expressions. When we replace a variable with a number, we say we are substituting for the variable. So if I have 3x minus 1 and I say x equals 2, then we're going to substitute that back in. Carrying out the resulting calculation is called the evaluating the expression. So we say evaluating the expression when we carry out the calculation. We say evaluating the expression given x or y or z equals something. That's us. That's the extension where we do the substitution. We want to evaluate 8 plus 6 times x minus 3 squared for x equals 13. So what we mean is we want to do the substitution first. So now we just have 8 plus 6, and then parentheses, so that x is now the 13 minus 3 squared. All right, from here, we're going to evaluate. So we're going to go through our order of operations again. So grouping. So 8 plus 6, and then we have times 13 minus 3, which is just 10, and that is squared. Now we do exponents, so we have x plus 6 and 10 squared, so 10 times 10 is 100. And like I said, single number in parentheses does not represent a grouping. I'm just saying that we're still multiplying on this 100. Now we go multiplication division. We only have one of them to worry about. So this is 6 times 100. So 8 plus 100, or 600. Then I do my addition. So I have 608. And that is all that is evaluating the expression. Do I did order of operations? Okay. So worksheet 2. Okay, yes, there's 3 of them. You have A, B, and C. You got different cases here. So A, you have one variable that you're replacing. Here, the variable duplicates in the expression and you're replacing it. Here you have 2 different variables that you are replacing. So take a moment, pause, work through these problems, and then come back here for a solution. So x is being replaced with 3. So instead of 2x minus 7, we have 2 times 3 minus 7. Now we are going to evaluate. So order of operations, no groupings, no exponents. We go to multiplication division. We only have multiplication to worry about. So 2 times 3 is 6 minus 7. Then 6 minus 7, negative 1. We've evaluated the expression for x equals 3. All right, so do this one more time. So here we have x 2 times, and we have a negative 2. So remember, this is squaring the negative 2. So it is negative 2 squared. So we're going to keep the parentheses around the negative 2. My suggestion is every time you substitute, put parentheses around the number you're substituting so you don't accidentally confuse yourself later. So every place I have x, I'm putting in parentheses negative 2, so we say that that negative is still coming with it. So this is negative 2 times negative 2. So negative times a negative is a positive, becomes positive 4. Here we have 3 times negative 2. Positive times a negative is negative, so negative 6. And let me go back there a second, because after I told you to do order of operations, I should not have done it that way. First things first, exponents. Negative 2 times negative 2 is the 4. I wasn't wrong the first time. I'm just realized that we're still learning. 3 times negative 2, negative 6. Now going left to right, 4 minus 6 is negative 2. So now negative 2 minus 4, this is all negative 6. All right. So like I said, I'm just doing this step by step, going through order of operations for the time being. There are other ways that you can get around this, especially when we start talking about properties of real numbers. You don't actually have to sit here and do this step by step like I am. Like I said, it's just because we're learning right now, I'm spending a little more time on this. Oops, there we go. Go to the next slide. There we go. We want to evaluate 2x minus 3y plus xy for all my x's are going to be -2s and all my y's are 3s. So we have 2 times x, which is -2, minus 3 times y, which is 3, x, which is -2, times y, which is 3. So all of these are just a bunch of multiplication. So if we've got groups of multiplication like this, you can do this all at one time. I'm going to do it step by step. First one first, 2 times -2, -4. Now we have -3 times 3. That's going to give me -9. So I'm just doing multiplication division going left to right. Now we have -2 times 3. So a negative times a positive is going to be a negative. So we get -6. Now doing addition, going left to right, -4 minus 9, -13. -13 minus 6, -19. So we're going to do formulas and mathematical models. So this is really an extension of what we were doing before. It's really just an extension of evaluating expressions given the value of our variables. We have an equation is formed when an equal sign is placed between two algebraic expressions. If I have 3x plus 7 and I have 5, these are two algebraic expressions. Now it's an equation. If I have 2 plus 7 times, or sorry, 2 plus 3 times 7, and I have 2x plus y, those are two algebraic expressions. If I put equality between them, now they're an equation. A formula is an equation that uses variables to express a relationship between two or more quantities. So you've seen a lot of these. Area is width times length. The process, sorry, there are 3 qualities there. The process of finding formulas to describe a real-world phenomena is called mathematical modeling. So when we figured out what area was, that was a mathematical model. Such formulas, together with meaning assigned to the variables, is called mathematical models. So we know that each one of these variables has a value, it has a meaning attached to it. We know that A is area. We know W is supposed to represent width, and we know L is supposed to represent length. So if I give a box and I ask for area, we know that this is the width and this is the length. So that's what we call mathematical modeling, is that we have a formula and we know what the variables are supposed to represent. So I'm not necessarily listing every formula that could be possibly used. These are just some examples. As I said, area is width times length. Perimeter of a square or rectangle is going to be P is perimeter plus 2 times the length plus 2 times the width, because we have 2 lengths and 2 widths. The perimeter of a triangle is just the sides A plus B plus C. So as I said, we know without being told, that's what we're looking at, length A, length B, length C. Area of a triangle. We know B is supposed to be base, H is supposed to be height. So if you want the area, it's 1/2 of the base times the height. Volume of a rectangular solid. We know that we have a width, we have a length, but we also have a height to get that area. Distance, we know, is rate times time. So it's whatever your speed is times the time it takes you to get there. So these are some other common ones we see. So Celsius to Fahrenheit, which we were going to use. If we want to know the temperature in Fahrenheit and we know it in Celsius, Well, all we have is use this formula here, and I can figure out in Fahrenheit. Simple interest, principal times rate times time. Area of a circle is pi times radius squared. Circumference is 2 times pi times radius, or pi times the diameter. And Pythagorean's theorem is leg A squared plus leg B squared equals hypotenuse squared. And quadratic formula is another formula that we use. We know that A, B, and C are supposed to represent coefficients on a trinomial, or sorry, a quadratic trinomial. And we use that to figure out what x is going to be. Like I said, I put some of these in here, so if you see them in the homework, ideally you don't have to go and look up all the formulas. But your homework is a little random sometimes, so you may have to look up a formula outside of the ones I provided in the PowerPoint. Okay, so as an example, the formula T equals negative x squared plus 361x plus 3,193 models the average cost of tuition and fees, T, for public U.S. colleges and for school years ending X school for a school year ending X years after 2000. So 2000 is the beginning of this formula, is what we're saying, and we're measuring years after that. Use the formula to find the average cost of tuition and fees at public U.S. colleges for the school year ending in 2016. So we know, apologies, X is representing years after 2000. So 2016 is 16 years after 2000. So what we want to do then is evaluate E equals negative x squared. Well, not even the x. We want to evaluate because we want to figure out what T is. Negative x squared plus 361x plus 3,193 for when x is 16. That is what we're being asked when we're given a formula and we're asked to find something. So we want to find the average cost of tuition T after 16 years, or 16 years from 2000, so in 2016. Let me erase all this. So we said x is 16. So all we need to do is don't worry about T, is what we're trying to find. We have negative. This negative is not included in the square root, it's outside of it. So it's negative, and it's just 16 that is squared, plus 361 times x, which is 16, plus 3,193. So in 2001, what this says right here, that is representing, or not, in 2000, that is representing the cost of tuition and fees, the average cost. We're going to see what it is now, 16 years later. So we are going to evaluate this. Ignore what T is. So negative 16 squared. So we need to deal with this square first because I don't have groupings. I just have a square. So 16 squared is going to be 256. You also could just plug this all in your calculator, but we're going to do this piece by piece. All right, the next part is I have the multiplication. So 361 times 16 is 5,776 plus 3,193. All right, so we can just put this all in our calculator at once. So negative 256 plus 5,776 plus 3,193. Assuming I did not make a typo in my calculator, that means that in 2015, average tuition and fees for college is going to be $8,713. All right, and that was using a mathematical model. Pretty straightforward. All right, so your next problem of 3 and 4, they're going to be going back and using formulas. So we have a Campbell soup can is 16 inches tall and has a radius of 2.5 inches. How much soup will a Campbell soup can hold? I can't remember if these are exact numbers or rounded numbers. Um, but think what it is you're being asked to look for and find the formula that is appropriate for it and fill in the information. Same thing here. Heat wave threshold. So the threshold for something to count as a heat wave in England is a temperature of 280 degrees Celsius or more. In Alaska, the threshold for a heat wave is 7 degrees Fahrenheit. So we got Celsius and Fahrenheit. So we need to convert one of these and figure out who has a higher heat wave threshold, England or Alaska. Take a moment, pause, work in these two problems, and come back for an answer. All right, so the Campbell soup can, I'm going to draw a little picture over it here in the side, and then I'm going to grab the formula. So we have a little soup can. So we know the radius of the soup can is 2.5 inches. We know the height of this can is 6 inches. So we have an R and we have an H. Now we want to know how much soup will the can hold. So we're being asked to find volume of a cylinder. Sorry, my brain froze. I'm pretty sure I spelled cylinder wrong. So if we go back here, oh no, I didn't mess it up. This right here, a cylinder says it's going to be volume E is equal to pi times r squared times height. All right, so we can get our formula here and go back. So you should have a pi key on whatever calculator you have. So pi is one of those examples of it's not a variable, it's a constant. So it is pi as a Greek letter. So this is an example we said like sometimes you have something that looks like a variable, but it's actually a constant. And this is a case here. But we want to find volume, which is V, we're pretty sure. We need pi. So either you can put in pi or you can use 3.14 for pi, either one. But we're going to have our radius squared. So the radius is the 2.5 squared times h, which is how tall my soup can is, my height, and it's going to be 6. Like I said, I'm going to do both of these in case you couldn't find a pi key on your calculator. So we will have pi times 2.5 squared. I'm just going to do this all on my calculator, times 6. So here, let me go back a second. So we're going to get an approximate answer. I'm going to say round to 3 decimal places. Squiggle line, because it's approximate. Approximately, this is going to be 117.8. Well, it's actually be 810 if we round it. So we probably should just round 2 places. Remember that we had a volume here. So area, if we were doing area, then that would be inches squared. Because we're doing volume, that means that we have inches 3 times. That will be inches cubed. So this will be in inches cubed. Here, we're not going to get an approximation because we're using 1.34 for pi. 1.34 times 2.5 squared. Take my times in there, times 6. So we'll get Close, but not exactly the same. 117.75. And once again, it's inches cubed. Or you might see cubic inches. So the heat wave threshold, once again, in England is 280 degrees Celsius, and Alaska is 7 degrees Fahrenheit. We want to know who has a higher threshold. Well, let's see, what formulas do we have available to us? So we have this formula right here. So let me write again on the side here. So we can figure out Fahrenheit given Celsius. We could do it the other way, but that requires us to do a bunch of solving, which is not necessary. So there's my formula. So we have my C right here. So we want to find Fahrenheit. So we're going to find the English temperature in Fahrenheit. So we see we got 9 divided by 5 times our Celsius, which is my 28 degrees Celsius, plus 32. So if you need to make it a little easier on yourself, just 9 divided by, oops, just a second, 9 divided by 5. Trying to get the whole thing in here in a second. That's going to be 1.8. So 1.8 times 28, that is going to be 50.4 plus 32, which is going to be 82.4. Remember that is degrees Fahrenheit. So I can go back here and take this out and say, all right, the threshold for England is actually 82.4 degrees Fahrenheit. The threshold for Alaska is 7 degrees Fahrenheit. Who has a higher heat wave threshold? It will be England.